Look at the two questions, children. Let's solve that. A cyclist is speeding at 18 km per hour on a leveled road, takes a sharp circular turn of radius 3 meter. What is the speed? 18 km per hour. The coefficient of static friction between the tires on the road is 0.1. Okay, so let's write the given. Speed of the cyclist is equal to 18 km per hour. Convert it into meter per second because that is your SI unit, yes or no? So how will you convert kilometer per hour to meter per second? Multiply by 5 by 18. And now tell me what is your answer? 5 meter per second. And what is the radius of the circular turn? It is 3 meter. And they have given the coefficient of static friction is 0.1. We have to find whether the cyclist will skid when he is traveling with 5 meter per second or not. Actually, we know what is the speed that we have to follow in order to avoid skidding while we are taking the circular path on a leveled road. What is the speed? Vmax is equal to root over mu rg. And in this formula, let's substitute all the given. Mu value is 0.1, radius is 3. G value we know very well. G is equal to 9.8 meter per second square. That is acceleration due to gravity. And for our convenience, for the calculation, let's check it is 10. And now the answer is Vmax is equal to 3 meter per second. Okay. And the speed that we have to travel in order to avoid skidding is only 3 meter per second. But at what speed the cyclist is traveling? 5 meter per second. So definitely the cyclist will skid because the speed of the cyclist is greater than the speed that we have to follow. Okay, for a safer limit. That's all, children. Let's go to the next question. Now let's do example 4.11. A circular racetrack of radius 300 meter. So they have given radius is equal to 300 meter. Is banked at an angle 15 degree. This is your angle of banking. If the coefficient of friction between the wheels of the race car and the road is 0.2. So they have given mu is equal to 0.2. Actually, they are asking us to find the optimum speed V naught to avoid wear and tear. The maximum permissible speed Vmax is equal to question mark to avoid slipping. Okay. So actually, I would like to remind you that we have studied two formulas in banking of roads. What are the two formulas? One of the formula you have studied, V is equal to square root of Rg into mu plus tan theta divided by 1 minus mu tan theta. Am I right, children? Yes. Okay, now I will tell you why we have to use this formula. This formula for the speed that we have to use only when the road has the friction. Okay, and also if we have to avoid skidding or slipping, then we have to know at what speed we have to drive. And actually, there is another question, is there no? There is another subdivision. What is that? Optimum speed. For optimum speed, there will be no wear and tear on the tires if the surface does not have any friction. Okay, so if the friction mu is equal to 0, then the speed that you have to drive the vehicle to avoid wear and tear is V is equal to root over Rg into tan theta. Okay, so this formula we have to use if mu is equal to 0 to avoid wear and tear. Okay, so now let's find optimum speed value. Question number A. Optimum speed. V naught is equal to root over Rg into tan theta. What is R value? So in the question they have given, it is 300 meter. Check it here. It is 300 meter. And the angle of banking is 15 degree. Even I have mentioned those in the given. Okay. So radius is 300 meter, theta is 15 degree. G value you know, the 9.8. Approximately it is equal to 10, tan 15 degree. Check your logarithm table for tan 15 degree. It is 0.2679. I will use the value directly. V naught is equal to root over 3000 into 0.2679. What is 0.2679 into 3000? It is 803.7. Now let's calculate the square root of 803.7. While we are doing the square root, you know that we have to take the double digits. So if there is no double digit, please include 0. And now tell me, 2 2s are 4, balance 4, take the double digit 0 3. And here, whatever the number you have obtained, just double it and write here 4. Now what number you have to put in order to get a 403? 46 6 are, check what is 46 into 6. It is only 276. Okay, 48 8s are, it is 384. Okay, so let's check 48 8s are. And now the remaining is 19. That is the decimal point, so I will also keep the decimal point. Bring the 70 down. And whatever the number you have obtained here, the last digit you please double it. And it is 16. Already there is 4. This one is carried to this 4. Okay, and now the number is 56. You have to write 56 here. And whatever the new number you are going to put here, the same number you please put it here also. So 563 into 3, what is the answer? 1689. Okay, you will get some denominator. And now the answer is V naught is equal to 28.3 meter per second. That's all. This is the value of optimum speed. Now let's do the second subdivision, maximum permissible speed. Among the two formulas, which one you have to follow to find maximum permissible speed to avoid slipping? The first formula. And the second formula is for optimum speed. Okay. What is the formula for Vmax? Vmax is equal to root over Rg into mu plus tan theta divided by 1 minus mu tan theta. Substitute the value of Rg and mu theta and all. R value is 300, G is 10, mu value 0.2 plus tan theta is 15 degree divided by 1 minus 0.2 into tan 15 degree. What is your answer now? 0.2 plus, first you tell me what is tan 15 degree. Tan 15 degree is 0.2679. Okay, in the previous subdivision itself, I have told you, you have to check the logarithm table in order to find this value. Now root over 300 into 10 is 3000 into 0.2 plus tan 15 degree is 0.2679 divided by 1 minus 0.2 into 0.2679. Now Vmax is equal to square root of 3000 into 0.2 plus 0.2679 is 0.4679 divided by 1 minus 0.2 into 0.2679 is 0.0538. Now tell me what is 1 minus 0.0538? It is 0.9462. So I will continue the values in the next page. Vmax is equal to square root of 3000 into, check the previous page, 0.4679 divided by, the answer for the subtraction is 0.9462. And listen, instead of solving it entirely, let's use the logic. 0.9462 is approximately equal to 1 and 0.4679 is approximately equal to 0.5. And now the answer is 3000 into 0.5. What is 3000 into 0.5? It is 1500. Let's take the root for 1500. Take double digits. 3 threes are 9, 4 fours are 16. Yes or no? So I will apply 3 threes are 9. The answer is 6. Bring the double digit number down. Double the number and write here. Whatever the number you are putting here is the same number you have to put it here. So 68 eights are what? 544. 68 eights are 544. Remaining is 56. Okay. And still we need some number. So I will apply decimal place. 0.00 I will take. So those zeros will come down. And whatever the number you have obtained here, you have to twice it. Now it is 16 and here 6. This 1 is carried to this one. So 7, 6, 76. And whatever the number you are going to put here, the same number you have to put it here. 767 into 7, 5369. Okay, let's apply 767 into 7. Okay, you will obtain some denominator. So what is the answer? Vmax is equal to 38.7 meter per second. That's all, children. They asked us to find the optimum speed and the permissible speed. We have calculated optimum speed as what? 28.3 meter per second. This is the value of optimum speed. And the permissible speed value is 38.7 meter per second.